Some time ago, I bought myself one of these volt amp watt meters. VAWs is what I wound up calling them. and um, the reason I wanted one of these, I found myself in a situation many times where I would say pass a current through a precision resistor, put a precise voltage on it, had a precision resistor, wanted to measure the current coming through it, and use that as a standard for some measurement I was doing. But while I was adjusting the voltage across the resistor, I was always very concerned about the power rating. Was I exceeding it or not? And you always had to kind of keep it in mind what for the resistance you had and the wattage capability of the resistor, what was the maximum current you could pass through, and make sure you didn't exceed that. And the whole time I was thinking, boy, wouldn't it be great to be able to read the wattage at the same time? Have the current, the voltage, have it calculate the wattage. No thinking, really. Just got to know what the wattage is, capability of the resistor. So I bought one of these meters. Didn't pay very much for it at the time. I think it was under $10. Might be a little more these days after COVID, but you can see it's a fairly small device. And one of the features of it was that you could use an external power supply between 5 and 24 volts to power all the electronics. And then you didn't have to worry about some minimum voltage on the external circuit that was going to be needed to power the electronics. And so I could wind up taking this all the way down to 0 volts, so long as I had the electronics powered from another source. So after that, then I needed to look at a case. I found the slope case, the source of these slope plastic cases, and I thought, you know what, that might just work. And after checking out the specs on it, I decided that yes, I could mount the unit within the opening of this unit here, but I was going to need to take one of these plastic blanks and cut out exactly the opening needed for that VAW meter. And I was kind of concerned about doing that. I thought, how am I going to do that really well? I mean, I could drill a hole and put it on a scroll saw and scroll saw it out. That's one way. What I wound up using was a Dremel tool and a disc, a carborundum disc or diamond disc, some people call these. Anyway, I was able to use that disc when I mounted this plastic cover in there. I could cut, grinding away the plastic, start in the middle and cut down and then work my way to the edges and so on. So the toughest thing was just outlining exactly the dimensions that I wanted, then following the outline with that Dremel tool. So what did we wind up getting? Well, let's turn this thing over so we can see the upside of it. All right, that's what the meter looks like. So we've got an on-off switch. We've got current terminals are a little more robust. We have some lightweight voltage sense terminals. We've got the meter mounted inside of it, and we've got all of the internal wiring going on inside this unit. We have a external jack on the side, and I have a 9-volt wall wart power supply that I use, and that powers everything. And then we have the back, which I mounted 4 rubber feet on, which then snaps in place. You put your screws into it, and you've got yourself a really nice, handy bench VAW meter. I'll give you a look at that a little bit later. Bear with me. Okay, so looking at the internals here, let's just kind of quickly point out a little bit about what's going on. We've got an SPST switch, which takes the power from the positive side of this jack, runs it over to here. Then we take the pivoting arm of the switch and we run it to the positive input. We take the ground to the other side of that jack. So that powers the unit. Then we have a voltage sense. That's this red wire that comes up and works its way around. A voltage sense winds up going right about here. And then we have the current section here. So here's the common line, runs to the negative post here and also to the negative voltage sense. So we run a jumper over there. And then we take the current directly from this large current post here and bring it to this leftmost terminal. So that's really it. Most of it was cutting out the box cut needed for that VAW to fit in there, and then drilling the holes for the terminals and the power jack and the switch. Nifty box, and I wind up with a pretty neat little unit for the desk. I think the total cost on this was somewhere around 25 bucks. So there you go. I will put it together and we'll give it a test. Okay, I've got a resistance box setting here with some high wattage resistors. The first two are 50 watts apiece, and then we got a 10 watter and a 3 watter. I'm plugged into the second one, which is 10 ohms at 50 watts. We're coming out with our positive lead running into the resistor. We have a voltage sense line coming back going to the positive voltage sense. And then out of the other side of the resistor, we bring the positive line back to the current terminal, positive current terminal. And then from the negative current terminal, we go back to the power supply. So now I can adjust my power supply back here, and I can observe the voltage, current, and wattage ratings as I do it. So here we go. I'm going to take this up to 10 volts. There's 10.04, almost 10.03. Trying to finesse it just a little bit there. She doesn't want to. 9. Yeah, 10.034 volts. We're getting 0.9655 amps. I would be getting 1 amp, but we've got resistance of these wires and the connectors and so on, and that's really what's causing the difference. If I was to shorten those up, then we would see exactly 1 amp, I would believe, right in that display. But we see we're drawing about 9.68 watts, and that's certainly not 50 watts, so we're good. We're probably warming that resistor up right now, but we're not worried about burning it out. And that really was the whole purpose. All right, well, thanks for watching. I hope this might give you something interesting to do. Oh, I also put labels on here using a Dymo label maker. Well, that's it.